Hello, Internet world. My name is Krista Oswald, and I will be giving a short recorded presentation, which I was supposed to be giving in Puerto Rico, and then due to COVID was supposed to be given live on Thursday, and then due to a migraine, the NAOC has been lovely enough to allow me to do a post presentation recording, and that will be linked to the NAOC via YouTube, where I will be putting up this video. First off, I will be saying that estaré hablando en inglés for this presentation because lo siento para mi español no es bueno. I am in the process of trying to learn Spanish, but I am definitely not there yet. So a big shout out to Juanita Hernandez, who translated my slides into Spanish so that they can be presented in both languages for this presentation. I'm going to be presenting on a paper that was recently published in IBIS, where we looked at how increasing temperatures were increasing the risk of reproductive failure in an alpine endemic bird to South Africa, the Cape Rockjumper. There are a lot of different factors that can affect birds throughout their nesting period, but basically the main measure we use for reproductive success is whether or not birds are able to produce fledglings. For most instances, a nest that produces one fledgling or more is considered a nest that has had reproductive success. We chose to study the rockjumper because a previous study had examined reporting rates for a few different birds across the Fambos biome, endemics as well as non-endemics, and had found that the rockjumper in particular had decreased reporting rates that were correlated with areas of their habitat experiencing the greatest warming. So the project that I was part of looked at a few different ecological factors that may be affected by temperatures and could be resulting in these decreased reporting rates in warmer parts of the habitat. One of these was that there was increased predation occurring at higher temperatures, which was then resulting in lower reproductive success and lower population recruitment, thus decreasing population sizes. A lot of previous studies have found that increased concealment in the area directly around the nest generally results in increased nest success, although there are a few studies that have found this depends on predator type. So increased concealment results in decreased predation for visual predators, but can result in increased predation for olfactory predators. Cape Rockjumpers are ground nesting birds. The Fambos that they live in is fairly sparsely vegetated, so they have limited access to concealment and instead tend to build their nests under rocky overhangs that are often quite open. So in this instance, we came up with the hypothesis that nests with greater nest concealment would have better protection from potential predators and so increased overall nest success, as in they would produce more fledglings. This is just an example of normal mountain fambos at Blue Hill. So this is the landscape that rockjumpers live and breed in. This picture is about 3 to 5 years of vegetative growth. The Fambos has a fire regime of about 7 to 10 years, so this is sort of a midpoint in the vegetative growth. The study was originally meant to occur over 2 full breeding seasons in 2017 and 2018. Rockjumpers breed anywhere between sort of late July, early August through December, and often still have nestlings into January. Just after our 2017 breeding season, the Western Cape province of South Africa had a series of wildfires that swept across most of the province and included a small portion of my main field site, the Blue Hill Nature Reserve. This gave us an unanticipated and fairly exciting different avenue that we could add as an additional analysis to the project, where we had habitat that had previously been unsuitable for rockjumpers due to the really dense proteas that had been there, now denuded and open for rockjumpers to move into. On the northern part of the map had previously had no rockjumpers in it due to the very thick growth, but after the fire swept through there, we actually found that rockjumpers started moving into that area within 3 to 6 months of the fire and did actually attempt to breed in the following season. So embracing this new and fun facet, we amended our hypothesis to be that nests with greater nest concealment, but also greater landscape cover, would have better protection from potential predators and so increased overall nest success. We collected predation data in a few different ways. We had trail cameras that we set up at every nest that we found. as well as a few infrared cameras that shot short video and were better for catching nocturnal predation that we set up whenever they were available at nearby nests. The main variables we collected were nest concealment, which was vegetated cover in a 1 meter radius of the nest, as well as habitat stage, which was based on individual territories and whether or not they had had a wildfire more than 3 years ago or 3 years or less. We also had maximum daily air temperature, which was recorded by a weather station set up at the field house. Our metric of success included whether or not a nest produced one or more fledglings. This was confirmed using both cameras as well as visual checks. If we didn't manage to catch a fledgling event on the cameras, we would do visual searches ourselves, trying to locate the family group and see whether or not they had fledglings with them. This allowed for some very cute footage that is available linked through this YouTube channel. If you want to see more, there are some videos linked to this YouTube channel where you can see either the happy ones of fledglings actively fledging, or there's also a few where it's a little bit more graphic and you can see the results of some of our failed nests. We collected data for 56 nests from 30 different territories over 3 years. Of the 56 nests, 46 of them failed. Of these failed nests, 19 we could not determine the cause of failure, unfortunately. Our camera setups and visual checks just didn't manage to catch the predation event. However, for 27, we were able to identify the predation event itself. Now here we were surprised that the majority of the predation events were actually due to boomslang. Boomslang is Afrikaans for tree snake, and the fynbos that rock jumpers inhabit does not tend to have any vegetation over 1.5 or maybe 2 meters in height. So there's nothing that would really be considered a tree besides the occasional olive tree. And it was quite surprising to anybody that we told about these results that the boomslang is such a prevalent predator in the fynbos. Our main analysis included a daily survival rate, which was modified from Mayfield. This included whether or not each nest had survived or failed for each exposure period. The exposure period is usually recorded as the number of days between checks. For us, however, this was pretty much in all instances 1, because with our trail cameras, we could tell daily whether or not nests were still active. We did an initial analysis of the year as well as nest stage, being either eggs or nestlings, as well as date. None of those were significant. So our main model included survival as a function of habitat stage, nest concealment, as well as the daily maximum temperature for each exposure period. After our main finding that boomslang were the main predators of rock jumpers, we did an additional analysis where we made predation a binomial of being either a snake or not a snake, and looked at this as predicted by daily maximum temperature as well. Now, contrary to our main hypothesis, we actually found that early post-fire habitat, so that which had been burned most recently, had greater success. We speculated that this might be due to increased visibility in the entire territory, where predators can be seen and driven off from further away. It could also be due to wind dispersing scent more easily, and so olfactory predators such as snakes have more difficulty finding the nest. And it could also just be increased predation of the predators themselves. Strangely, we actually found no significant effect on survival based on nest concealment directly around the nest. Well, the boomslang was our main cause of predation. We did manage to catch a few different varieties of predators, which included a unknown species of field rat, as well as Cape gray mongooses, honey badgers, as well as one instance that seemed to be a combination of ants and starvation, where the dominant male in the territory disappeared between nest checks, and so we're not actually sure what happened to him, but the female was unable to keep up with feeding as well as keeping the nest area clean. Now, we also found that the probability of nest survival decreased as temperatures increased. This is probably due to the accompanying increase in snake predation, which also occurred at increasing temperatures. Our study highlights the importance of examining interactions between different ecological effects. In terms of climate change for South Africa, it is predicted that things like wildfires will become more common, as well as increasing temperatures. So If we interpret that from our study, we find that increasing wildfires from climate change might actually be good for rockjumper reproductive success. But of course, there is a balance with the fact that increasing temperatures will bring increased snake activity. So it becomes a little bit more complicated, and our study just highlights the importance of examining a few different ecological factors when trying to determine the actual long-term consequences of things like climate change. We had funding provided by Rhodes University, Nelson Mandela University, the Fitzpatrick Institute, the Tigerbird Bird Club, Cape Nature, the Animal Behavior Society, BirdLife South Africa. We also had an additional 2 field assistants come out in 2018, Cameron Brock and Kaylee Ping, and we could not have done this without their hard work as well. Now, I obviously can't do questions live. However, if you have any questions for me, please feel free to either write them in the comments on the YouTube video or else send me a tweet, and I will be happy to discuss this further.